All right, so we are getting recording started, even though we are about a minute off. I'm not sure whether you guys know the trick. One way to utilize the YouTube recording is to use the closed captioning because you can download the entire transcript as a text file. Then you look for certain words, and then it will give you the time, of when, about when into the lecture, that word appeared. So that makes it easier to search for specific segments of the lecture.
How accurate is closed captioning, though?
Hmm?
How accurate is closed captioning?
It is surprisingly accurate, even with my accent. Before, like years ago, it was really horrible. But these days, it's actually pretty good. So let me just kind of go to my own videos and show you what I mean by that. So we can actually go back to the previous lecture, which I think is 27th. So if I go back to this lecture first, there we go, and I pause
All right.
the playback. And what you can do is go to the closed caption. There's a setting thing that we can download. Okay, where is it? There's a place to download the transcript. I cannot remember. Show transcript. There we go. There we go. So under transcript, that's the actual, the transcript, and it shows you the time. So you don't even have to download anything. So let's say last time we probably mentioned the word exponent quite a few times, right? So we look for exponent, and yeah, here we have a list of mentioning of exponent. So there we go, and that makes it easier for you guys to locate the relevant section of what you're looking for, especially if there is a word or a phrase that kind of marks what you want to look. So I mean, I'm doing this not as the owner of the video, so you guys can all do this too, which I think is kind of helpful. But if you read the actual closed captioning, it's pretty accurate. I wouldn't say 100%, especially when it comes to technical terms, but it is good enough that you can use it to help you study and locate just one particular section of the lecture to review. All right. So is that okay? Does everybody get this part? Okay. All right. And well, we don't have as much of a problem in this class, but in some of my other classes, some of my students can really use the closed captioning option to change the language. So let me see, how do I pop that up again? Because I want to look at the closed captioning options. There we go. So you can also, some people can turn on auto translate, which means it will translate from the English closed captioning to whatever language you choose to translate to. So that's kind of like, it's really kind of cool. I've never used it. Let me give it a try. I'm just curious.
Bulgarian.
Nope, Chinese, because I understand that one, right? So we'll give it a try. Right. So what we're gonna do today is, okay, first thing first, we have our exam one on this Thursday. So keep that in mind, and try to arrive, on time
It's
or
actually
earlier
pretty
if you
accurate.
want to have the time to. Even the translation part is pretty accurate. So it's a good resource. I think it's a good resource. All right. All right. So with that said and done, I have already started the recording for today. So what we'll do today is to continue the discussion of how to translate a base 10 scientific notation into base 2 scientific notation. It is not quite exactly double, but it is very close to what you need to make a double. Last time we talked about how to start with a negative exponent and end up with a binary representation. So what we'll do today is I am going to show you the lab slash homework assignment, for this week. Okay, so from today all the way to next Wednesday, you have a programming project. So let me show you what I mean by that. Scrolling down, we are in the middle of the semester already. I know this is only week 7, but because of some additional holidays, this is technically actually kind of the middle of the entire semester. Yep. It's week 7. We are at the end of week 7 already.
Time goes by so quickly.
Yeah, and I was so glad that we do not have a day off next Monday. I know most people are saying like, "Oh, I wish I had a Monday off." No, we cannot afford to have a Monday off because we got a lot of topics coming up. All right, so this is the lab, and I'll show you the description first. You cannot access it just yet, okay? This is the description of the lab, and the way you do this lab, you need to have an environment in which you can write programs in C, C++. Um, so let me just kind of make a query, okay? I'm going to ask you guys, how did you write programs in your CISP 360 class?
C plus plus.
Okay, but which C++, which environment?
Well, we use a common.
Okay, so go ahead. I'll just ask people like sequentially. Go ahead.
We use code blocks.
Code blocks. Code blocks. Does anyone use something else? Okay, go ahead.
C-line or code blocks. So C-line.
C-line?
Yeah, or
Okay.
code
I just use Visual Studio Code.
Visual VS Code. Okay.
VS Code is
VS Code.
I use a REPL.
Replit?
REPL?
Yeah.
I like
Okay.
REPL. Yeah.
Yeah. Okay. Great. So all of those tools will work for this homework assignment. So if you remember or if you still have those tools installed, that's fine, okay? We are not using any exotic features of any particular version of C or C++, so just about any C compiler would do. It doesn't even have to be C++, just regular plain C is going to work as well. So in this particular description, I also give you a link to online GDB. So in case you do not have a specific environment that is ready to go, this is always ready to go because it is just a web page. So this is what it looks like, and I signed in already. So once you sign in, it can save programs for you. So when you write your program and you save, it is saved in the cloud, and it doesn't cost you any money. So you can sign up for free. If you worry about disclosing your actual email address and you don't want to get spammed, just sign up for a free another free Google account and only use this, with that new Gmail account, that's perfectly okay. But I find this to be quite useful. Let me show you what I mean by that. So if I switch back to my description here, the second link is a source file. So with this one, you kind of have to click it, and the funny thing is Canvas is trying to render it, but it doesn't know how to render a source file. So what you need to do is to download it and put it in a place that you can remember. So I'm just going to put it in my temp folder because I don't need to store that permanently on my computer. So I'm going to put it into the temp folder. All right. So what you can do now is go back to online GDB and basically copy and paste the program to basically paste over this particular program. And the way to do that is, I mean, at least for me, I delete the entire content here, and then I switch to a command line prompt, which you cannot see, unfortunately. Let me see. I can make a new one so you can see it. There we go. All right. So from my perspective, using Linux, the way that I do this is I run a command called xclip, and then I redirect the file that I just downloaded, which is called what again? Negative exponent? No. Okay, let me take a look. Monolith. There we go. Monolith-1.c. So this will put the entire program into my clipboard, and then I just do a Control V and paste it in here. Obviously, in Windows, you're going to use Notepad, right? You open the .c file in Notepad, and then just do a Control A, select all, Control C to copy, and then get back here and do a Control V for paste. So that's one way to do it. That's one of many ways you can, you can maintain your program for this particular assignment. All right. So let me just kind of briefly describe let my description briefly describe what you're supposed to do. Your code should take the struct number, okay, so struct number is a particular type that is defined in the program itself. In the function that you need to work with, which is exponent 10 to exponent 2, this is actually incorrect. I got the wrong name. Instead of fixing the name, I will just kind of show you what you're supposed to be using. I got one already up and running because this is from my other class. I'll get rid of that one. And so this is the subroutine that you need to modify. E10 to exponent 2, so it's a little bit off compared to the description. I can fix that too. You can put a breakpoint here. In other words, you're basically asking the program to pause its execution when it gets to line 160. Everything before that, you're more than welcome to check out what is parse, which is taking what is equivalent to the regular expression that we talked about in the previous class, and convert the entire thing into the structure that we need in order to get your code started. Okay? So I'm going to run the program now. I want to show you how to use this in online GDB. If you are using your own debugger or your own environment, you will probably have to find out how to supply command line options when you run the code. Okay, so that part depends on which environment you are using. So before I go anywhere else, let me just kind of show you what I mean by that. So if you're using VS Code, you want to look up VS Code command line option to program being debugged. There we go. So let's see. There should be a way to specify the command line options. Nope. This is how VS Code itself starts. I'm looking for the instruction to run the program with specific command line options. So you probably have to dig a little deeper. I know how to do that with code blocks. Code blocks is easy. So if you go to code blocks, there we go. And the answer is go to project menu and then use set programs arguments. So this is how you do it in code blocks. Is that okay? For those of you who are using code blocks, I can actually show you, well, maybe later. I can show you how to do it exactly in code blocks. But since I do not use VS Code, so for those of you who are using VS Code, you need to do some research and find out how to specify the command line options when you are running the program that you're debugging. All right. So any questions about all that stuff? Nope. Okay. All right. So getting back to online GDB. So now I'm ready to run the program. But before you run the program in online GDB, you have to specify what language this program is written in. C is going to be fine. Okay, this entire program is really just written in C. On the other hand, if you have the habit, I have to say inefficient habit of using C out, to check out, to test your program and to debug your program, then you probably want to choose C++ because C out is not in regular C because it's object-oriented programming already. But for the most part, I try to discourage people from using cout or printf or anything like that for debugging. You have access to a debugger. You try to use the debugger for debugging. So I will choose a plain C, but you can choose C++ if you want to. It does not interfere with the program.
So you're just saying, just to clarify, not that you're against using C out, but just not to debug, right?
Yeah, as a habit, it's not effective because if you use cout, you just end up with a lot of stuff that you have to kind of filter through, kind of visually, um, and it doesn't stop the execution either. So cout just kind of the program keeps going. It's just cranking out a lot of output, and then you have to visually process all that stuff. But if you use a breakpoint, on the other hand, the program is really pausing its execution, which means at that time, you'll be able to check out things or even to make changes before you continue, you ask the program to continue execution. So I will demonstrate all that stuff. Okay, so I'll get to that part. All right, so now I'm ready to debug the program. And instead of using run, which does not let you pause the execution of the program, you want to use debug. And I'm pretty sure there's an equivalent button on VS Code as well as code blocks. Just about anything has this option. So you click on debug, it will compile the program. And all right, so I set a breakpoint already. So to begin the execution of the program, because right now the program has not even started. So begin the execution of the program, you type R for run. You can type run if you want to, but you can also just type R as an abbreviation of run. Now in GDB, the way you specify the additional argument is to use it's just to include the arguments after R, which in this case is dash n space and then whatever value that you want to convert, which I'm just going to use negative 1.23 times 10 to the power of negative 45. This is just an example, okay? It's just an example. So you have to give the program a scientific notation in base 10 in order so the program would use it as the value being converted into whatever representation the homework assignment is asking you to convert it to. Are there any questions at this point? Okay. So in code blocks, for those of you who are using code blocks, you don't have to use the R. The R is a GDB command. If you're using code blocks, this is the portion that you need to enter as the command line options, which is just dash n minus n, lowercase n, with a space, and then whatever base 10 representation that you want to convert from. Are we okay so far? Are there any questions? Okay. I'm not seeing any questions. All right. So I'm going to press the enter key. So now GDB is starting to run. And when it gets to what we call a breakpoint, it will highlight the line that is stopping on or it's pausing on with the green rectangle. And at this point, the program is not running anymore, which means you can actually examine stuff if you want to. So I can actually say, okay, tell me what is n. So n is a structure. It has 4 members. The first member is called sign. It is a 1. And that makes sense because the value that I need to convert from is a negative value. And that's why the sign is a 1, which is consistent with how we use bit 63 with a double precision floating point number. The second part is the coefficient, which is kind of the mantissa, but I changed the name from mantissa to coefficient because the mantissa has to be normalized. Okay, the proper use of the term mantissa means it is a coefficient, but it is normalized. Since this one is not normalized because it is 123, I have to change the name to coefficient. Are we good so far? Okay. And then we have E10, which is the exponent of 10, which is negative 47. It is not negative 45 because the coefficient changed from 1.23 to 123. So if the coefficient is 100 times what it used to be, somewhere else I have to divide the whole thing by 100. Decreasing the exponent of 10 by 2 has the same effect as a division by 100, and therefore the value being represented should remain the same. E2 is representing the exponent of 2, and that is the part where you will be adjusting the most. Okay? Are we doing okay so far with this program? Does everybody understand what is a structure, which is also basically a class? All right? So a way to correlate or relate the term class and the term struct is easy. If you know what a class is, a struct is a class where everything is public by default. That's it. Okay, and because I'm using plain C instead of C++, I cannot even put a member function, or otherwise known as a method, into the definition of a struct. So in other words, a struct is a very much simplified version of a class. It doesn't have the flexibility. It does not have a lot of the fancy stuff that you can do with the class. Everything is public, and you can only have data members. Is that okay? All right. Yep.
Could you explain what the dash n does in GDB?
So the dash n has nothing to do with GDB itself. It has to do with how the program itself is designed to run on the command line. So when you run the program, I did not want to hard code what string I wanted to convert into the base 2 representation. So I would actually be able to specify that on the command line. Yeah, I can show you what I mean by that as well. Okay, but right now I'm just going to use online GDB as an example. All right. And online GDB has one really annoying feature, and that is if you do not do anything, it's going to time out. It will kill the debugger, which means when you're debugging, out of a sudden, out of nowhere, it will reset. It doesn't kill the program itself. In terms of the editor, your editor will still have the same program, but it will kill the debug session, which means if you're in the middle of testing your program, then you have to start from the beginning again, which is really annoying. All right, so now we can single step. So to single step, there are probably a few ways to do it, but I don't have enough screen space to see that portion here. Oh, right there. Step over and step into. So the difference between stepping over and stepping into is whether you want to continue execution step by step into the program, into the function being called. So right now it is a function call. So if I use step into, it will get into E10 to exp2, and it will stop at the very beginning of the function. If you use step over, it's going to go to the return 0 right away. It will call the function, but it won't stop. It won't pause when you get into the function. So that's the difference between stepping into and stepping over. So I'm going to step into, which is also known as just step as a command. So you go step, and now we are in the function of E10 to exp2. And you can see the only parameter of this particular function is pn, which is pointer to a number. Okay, that's why I call it pn. And it is a pointer to a struct float 102. Okay, you don't really have to know exactly how the struct is defined because right now, because you saw that earlier already. Where did you see it? Right here. Because this is n, and what the function is getting is the address of n. Are we good so far? So now we want to, this is where you need to put your code. Okay, in this function, convert the number pointed to by Pn from base 10 coefficient and exponent to base 2 coefficient and exponent. Okay, so that's the description of what you need to do, which is also in the description of the quote unquote quiz here. Are we good? Are we doing okay so far? Yes. All right. Is everybody relating what you see here? What is in the sign, the coefficient E10 and E2 to the spreadsheet that we talked about in, I think, the previous class. Is that okay? So you want to make that correspondence because the spreadsheet is telling you what kind of logic you should be using. All right. All right. So that's it. Okay. You just have to put your code here. The objective of your code, okay, what you're supposed to accomplish, is to take the struct number pointed to by the parameter Pn, preserve the value being represented. So the coefficient, yes, I have a typo here, but this is supposed to be coefficient times 2 to the power of E2 times 10 to the power of E10 should remain the same between the time you first get into the subroutine to the time that you get out of the subroutine. Is that okay? Does everybody understand what that constraint is trying to tell you? That's basically what we did on Monday. So once again, the spreadsheet that I used on Monday is going to be really helpful when you need to think about how to approach this particular assignment. Okay, but there's further constraints. In addition to this equality, the coefficient should end up as a value that has bit 63 set. The mantissa in this case is 64-bit unsigned integer. In other words, yes, I know that in a real double, the mantissa or the coefficient only has 53 bits, but in this case, I'm just making it easier and use all 64 bits. We have more precision than we need. Because guess what? If you have too much precision and you say, I don't have that many bits to represent this kind of precision, it's easy to truncate. If you have too many bits to start with, it's always easier to say, oh, I don't really need those least significant bits. It's better that than not having enough precision to begin with. The second requirement is E10 should be 0. Well, that is not surprising because that's exactly what we were trying to do on Monday, even though we did not finish the whole thing because it's going to be really tedious. But I showed you how to increment E10 up by 1, okay, gradually. E2 can be any integer. It is signed. The representative value V should be preserved as much as possible, which basically means it is not going to be entirely the same, but it should be as close as possible. And then we have your entire program should not use anything that relies on float, double, or functions from math.h. Okay, so that was also emphasized when I talked about the approach on Monday using the spreadsheet as a demonstration. And then you also need to comment your code. In other words, you have to tell me what the loop is doing, why you choose the condition to be the way the condition is set up, and so on. In the GDB console of online GDB, do the following. Put a breakpoint at the end of EXP10 to EXP2. This is how you can check whether you got the right result or not. You can click slightly to the, it should be to the left of the line number to toggle breakpoints. So if I get back to GDB, yep, see, it has timed out the debug session already. So this is a little bit annoying, yeah, but it is a very easy interface to use. For those of you who are using Replit, does Replit has a debugger built into it? My Tuesday, Thursday class said it does. Hmm?
It should, yeah.
It should? Okay, let me just double check that first. Because just in case you guys want to use Replit, I want you to be able to. I'm pretty sure I have signed up already. Let me check that. Oh, okay. So continue with Google. I might have used my personal account. All right. All right, so we want to create a plain C or C++. I'm just going to pick plain C, and the title is test, and create Replit. And I just pasted the entire program in here. All right, so let me click that, close. All right, so let me see how I can debug the program. If you guys have tried it already, you can just kind of let me know how to do it. Because I want to debug the program. I don't want to just run it.
I think on the school on the left,
On the left,
way left. Yeah.
there's version control, that's log, that's debugger. Okay, there we go. All right, so we'll go ahead and click on the debugger. So now I need to figure out how to provide the command line, the -n, and then the base 10 scientific notation. All right, so do we have an option to do it? Because if we don't have an option to do it, then it cannot be used. Next breakpoint, skip, run. Hmm, does not seem to give me that option. So, that can be problematic because I'm not seeing an option to let me enter the command line options. So I can, oh great, it's a video. That's not debugging because it's just running the program in full speed. Hmm. All right, so it may or may not be a suitable, platform. If this doesn't work, you can always just kind of go back and use GDB, online GDB, because I know for sure online GDB works.
What are you trying to do?
I'm trying to specify the dash n and then the negative 1.23e negative 45 as the command line option, because that is needed by the program to know what you're converting from. Because otherwise, how do you specify what base 10 scientific notation you're converting from? So it does not appear to me, at least now, that Replit has that feature. So maybe I can find it later on, but I'm just gonna move on and talk about the rest of this description first. After compiling, use this command to run the program, with a test case. So this is exactly what we did earlier in class. Not exactly the same number, but it's the same approach. When the program stops at the breakpoint, you can examine the expression, okay, not expressing, but expression, star pn using the gdb command of print asterisk pn. And so that you can check your code, the following command running in GDB is like this. And the way it should update exponent, the mantissa, which is coefficient now, exponent 10, which is E10, and exponent 2, which is E2, is now in this log file. So this is just a gigantic log file to show you if this was the actual input, the number being converted. This log file will show you how the coefficient E10 and E2 should be changed. So do you guys want to look at the log file just to get an idea of what it looks like?
Yeah.
Okay, sure. So click on that. And Canvas probably doesn't know what to do with it also. So I'm gonna have to download it and open it on my local side. I'll just do that. All right, so I put it into my temp folder and go to my command line interface and show you that. It's called, what again? Sample one. Sample one. Oh, it's in the temp folder. All right. So this is what it looks like. It just shows you, the changes to the coefficient. It started off as 123, and then it got doubled, and then E2 started off 0, and then it got updated to -1, and so on. So it gets to a certain point. Okay, so if you just kind of scroll down, it gets to a certain point, and then there's a change. So by the time the coefficient became this gigantic number here, this is the last value that I can represent in a 64-bit integer. If I double again, it's going to take more than 64 bits to represent it. So that is when I say, um, we cannot double that anymore. So instead of doubling, I do a division by 10 with rounding, and as a result, the exponent of 10 is incremented from negative 44, excuse me, from negative 40, it's incremented to negative 43, and then we double again and double again, and then the increments again, and so on. So this is basically Excuse me. So this is a way for you to check whether your code is working or not by putting the right by putting the breakpoints at the right places. You can now check whether your code is doing the same thing or not. Are we doing okay? All right. Okay. And the final value is also important. So if you just kind of fast forward, this is the final answer. The exponent of 10 will become 0. The coefficient should become this particular number. And then the exponent of 2 should become negative 213. So by the time of your execution, the execution of your code, and you're not quite getting to these particular value, E10, coefficient, and E2, then you need to check your code because something is not working, or at least not working entirely. Is that okay? So this is a way for you to try to debug your program because I'm not only showing you the final answer, I'm also showing you along the way how those members of the struct member that is pointed to by PN should be changed. Is that okay? All right. So if I go back to the description, oh, it's still trying to download to display it. There we go. And that pretty much sums up what you need to do for this particular assignment. You have until next Wednesday to turn it in, so you have 1 week to do this. This is not going to be a one lab only thing. I mean, I'm pretty sure some of you can do it if you try to push it, but I don't want to give you the pressure because I would much rather you guys spend the time to understand what you need to do, looking at the spreadsheet, and then come up with the actual code to do it. All right. So today's lab is going to be really kind of open format. In other words, I do not have any structured activities for you guys to do. You'll be basically starting to implement this program. So you got a few choices, okay, for today's lab. One is, okay, finally we got a day where there's no actual lab to do. I can do this on my own, so I'm gonna leave at 10:20. Noontime, about 11:50. That's fine, okay, it is not a problem. On the other hand, if you say, I really want to, at least I want to know the tool to do this, so I will try to replicate what Tackton did earlier to set up online GDB, to copy and paste the program, set up a breakpoint, stop it, look at what the pointer is pointing to, and so on. You're more than welcome to start writing the code at the end of the lecture and starting at the lab time. So this way I can help you to make sure that you got everything set up to continue to write the program. But if you're proficient, you got the tools installed already, and you say, I don't really need that help, hey, you don't have to stay during the lab time. Are we okay so far? Yep.
So is this due by the end of lab next Wednesday or just Wednesday before class?
Before class.
Okay.
Yep. So let me specify that. The reason why I make it before class is I don't want people to miss the lecture because they're continuing to work on the program. So I will set the due date right now and also release it or publish it so that you guys can see it. So it's going to do, okay, what is next Wednesday? Today is the 5th. Yep. So +7 is the 12th. So it's going to be October 12th. Yes. Okay, I think I can add at 10:30 a.m., which is when the lecture starts. And there we go. And I'm going to go fix a few things in the questions because I had a typo here. It is actually just E10 to exponent 2, not EXP. Oh, got to click that first. Now, in terms of point value, it is only 4, which means it's not going to be a whole lot. But it is still important that kind of go through this exercise. And I think I made a few other typos here. So this is supposed to be E10. E2, this is supposed to be coefficient, and then I also made that error in the math function here, so I'm going to fix that too. Coefficient, there we go. And then E2, E10. So that's all correct now. I think I fixed most of the problem. This is supposed to be coefficient. Let's see. I think I had another grammar mistake somewhere, but I cannot remember where I made it. Yep.
It's further down. You misspelled compiling.
Oh, misspelled compiler?
Yeah, just scroll down.
Oh, okay.
Wasn't right supposed to be left?
Yep, that's right. It is. You're correct. The right is supposed to be left. Because if I said you're right, the right is supposed to be left, that makes it even more confusing.
There's also another EXP10.
Yep. So here's left, E10 to EXP2. I think there was one more mistake that I made, but I cannot remember where I did it. I think the main point is correct already, so I'll just go ahead and save it now. And save and publish. There we go. So now you guys have access to this particular program or this assignment. It's 1 week long. So what are you planning to do? I'm going to procrastinate. I'm going to procrastinate for 6 days and then I'll get started. Or to some people, it's 6 days and 12 hours and then I'll start. And then for some other people, it's going to be 6 days, 23 hours, and 55 minutes, and then I'm going to start. Go ahead.
I will have to review my C++ and C because I took Java for my object-oriented programming. But it's okay, but I've had
Okay.
exposure
To
of
C.
and C++.
It's mostly the pointer stuff that you need to check because Java has no pointers.
Yeah, I'm quite familiar with the pointers because
Oh,
I
okay.
learned C before starting school.
Okay.
Yeah.
The other stuff, the loops and conditional statements are almost identical between the two, so that would not be too big of a deal. The only thing is Java is far more picky when it comes to type checking because you cannot look at an integer and just say, oh, this is an integer in the context of a condition. So if it is non-zero, it means true. If it is zero, it means false. In Java, you have to compare to zero, to turn the integer value into a Boolean. But in C and C++, it can be implicit. So that's going to be an easy transition because you, at the worst, you just specify more code than you need to express the same thing. Yep. Yep.
I'm assuming we cannot turn in a C++ file on a campus, correct?
You are going to turn in the entire program.
Okay, so
Yep.
can.
Yep. So what you're going to turn in is the entire code.
Usually I just turn an RTF file and then turn it.
Say again?
Sometimes, like, for some reason, like, some professors have us turn in, like, a notepad and then that's needed.
Yeah, in this case, you just turn in the source file. Yep. Any other questions before we talk about positive exponent? Yep.
Would you be able to share the spreadsheet you made on Monday?
It's shareable. It's in the shared folder.
It's already shared. It was shared from the moment it was created. And I did another one for the Tuesday, Thursday class. I mean, you guys can check out the lecture from the other class as well. Because even though I try to be consistent when I teach the content of the class, there are changes and there are variations. So if you want to say, I want to check out the other example that you went through in another class, you can check out the Tuesday, Thursday class. All right. All right. So are we good so far? In fact, I am going to give you another spreadsheet today. which illustrates what to do when you have an exponent of 10 that is positive to begin with. So this is going to work exactly the opposite way, or I shouldn't say exactly, but mostly the opposite way. So let me get to a drive. Okay, I don't have one, so I'm going to just start a new tab here. And then we go to CISP310. And because I'm creating the spreadsheet in the shared folder, and that's why it is shared to begin with, from the moment I say new. So I create a new spreadsheet, create and share, and I'm going to name the spreadsheet after the base 10 scientific notation that we are converting from. So this time, let me think. Let's try 3.14 times 10 to the power of, let's try some insane number here. Not too insane, 80. The idea is I have to make sure that you will be forced to use the representation that to use the logic that you need to implement in your program. All right. So now we have the coefficient, right? So coefficient. We have E10, we have E2, oops, E2. The sign is not a big deal because the sign is 0 in this case. We simply do not have any, the value is being non-negative, and that's why the sign is 0. And then we also have V, just to double check after each step that we have preserved the value up to this point. And then we have this one here, basically indicating, do we have room for division by 10? The reason why we have this column E to indicate whether we have room for another division, multiplication, I take it back, another multiplication by 10 is because in order to decrement E10, I need to multiply the mantissa or the coefficient by 10. So I'm going to just say here, room for another times 10. Okay, there we go. All right, so now we're going to start with the coefficient. This number is going to have a coefficient of 314 to begin with. And then the exponent of 10 is going to be 80 minus 2, which is 78. The reason why it is 78 and not 80 is because the 3.14 became 314. In other words, it is 100 times what it's supposed to be. In order for V to be preserved, I have to divide it by 100 somewhere, and by decreasing the exponent of 10 by 2, I accomplish exactly the same thing as division by 100. E2 is 0 to begin with, and then the value is the easiest part, because what it is the coefficient times 10 to the power of E10 times 2 to the power of E2, and we got it back. So at this point, I have just verified that the initial setup, which is exactly what you would see in the program that I gave you guys, is correct. Okay, so the logic is correct. So now, how do I check that there's room for another multiplication by 10? So once again, I cannot use 64-bit integers in the example. I can only use 32-bit integers in the example. So how do I know that if I multiply the coefficient by 10 again, it would still be okay? I still have room for that. What is the condition that I need to set up for column E? Exactly what I said, right? If the coefficient times 10 is still less than or equal to the largest value that we can represent using a 32-bit unsigned integer, which is 2 to the power of 32, and then the whole thing minus 1, then we're good. Is that okay? All right. Then what do we do next? It's like looking at this and go like, well, the coefficient has plenty of room, right? The plenty of room to multiply by 10 and not to exceed 4 billion, which is basically what the range of an unsigned 32-bit integer is. So we can now look at this and go like, oh, that's easy. We'll just say that, we just multiply this thing by 10, and as a result, we can decrement this by 1. And we're going to have to keep this one the same as before. And this one, I'm going to use the same formula, but to make sure that it is still the same value. This one I can just copy from the previous one, just to make sure that there's enough room. Are we doing okay so far at this point? What I have just done in order to get a little bit closer to what we want, which is to make E10 equal to 0. In this case, E10 starts off with a positive integer, so to get it to 0 means we have to decrement it. All right, so we can do this for a while, and then at some point, we cannot do this anymore. So I can now just copy this row and just go like, we'll just give it a few tries. And before long, we basically come into the conclusion of, uh-oh, on row 9, that's when we need to get out of the loop, okay? So what we'll do, what I'm going to do, is to say this is as far as we can push it before we run out of space. This is the last value that we can use for the next cycle. Are we doing okay so far with this? Okay. So the next 5 columns is going to be set up about the same way. It's just a question of, what do I use as the initial value? I'm just going to make the columns a little bit smaller so this way I can pack more stuff on the screen. The header is going to be the same, so I'm just going to copy the header the same way as before. Now the question is, what is the new coefficient that I need to deal with? Well, I'm going to pick this one. Okay, so the new coefficient is going to be this one here, and I would just copy everything the same way as before, so I can just kind of copy these 3 like that. And then to check whether there's enough room, I have to do a fresh copy. So what I have done so far is simply to say the last iteration of the previous bunch of calculations is going to be my new starting point, because at this point, I can no longer multiply the coefficient by 10, because otherwise it's going to exceed what I can represent. So the question is, how do I make it so that it has room for another multiplication by 10? Yes?
I'm not answering that question, but I think your columns are off just a little bit.
Are they?
True should be under room for 10, right?
You are right. Okay. Yep, I did make that mistake. Thank you. So we'll go ahead and get rid of this. And instead, we have to copy both of these over here so that we have the V. All right, thank you. Okay, so let's get back to the question that I had earlier, which is, now that we know the coefficient is using all 32 bits of a 32-bit unsigned integer, there's no room for another multiplication by 10, but my exponent of 10 is still 72. What am I going to do?
Power of 2.
Okay, so it does have something to do with the power of 2, but that usually indicates something that you're doing to the coefficient.
Multiply it by 10, the coefficient multiplied by 10 so that the exponent would decrease by 1.
But we have done all of that up to the point of, yes, this is the last step, because if we do this one more time, we won't have enough digits in the 32-bit unsigned integer. So we already have pushed the 32-bit unsigned integer as a coefficient. We have pushed it as far as we could now. So what do we do to make room for another division by 10?
Divide it?
Hmm?
We divide it?
Yes. But what do we divide it by?
If you divide it by 10, then
we defeat the whole purpose, right? Because if you divide the coefficient by 10, then to make up for that division by 10, you have to bump up the exponent of 10, which is undoing what we just did before. So what do we divide it by? It's not 10, it's 2. Exactly. Okay, very good. So now we need to divide the coefficient by 2. Okay, so we say the coefficient is what it used to be and divided by 2. Wait, but every time you divide, you're going to lose some precision. So we need to do the rounding thing, right? What do we do this time? Last time it was add 5 first before we divide it by 10, right? But that only has to do with 5 is 1/2 of 10. This time we have to divide it by 2. So what do we need to add before the division? Exactly. Good job. Okay. That's exactly what we need to do. So we take the floor of whatever this number is plus 1, then the whole thing divided by 2. So that is a division by 2, but with rounding built into it. All right?
What? Why is it one again? One because
Because we want to do the rounding.
it was five last time though.
It was 5 last time because the denominator was 10, and 5 is 1/2 of that. And this time the denominator is 2, and 1 is 1/2 of that. So that trick still works. As long as the denominator is an even number, I can continue to use that trick.
That has to do with that rounding function that we looked at, right?
Yes. Yes, it has to do with,
The equivalent.
it's too much trouble to set up a Zerno. I'll use the whiteboard instead. So it has to do with rounding. The round of x is really the same thing as the floor of x plus 0.5, and then you take the floor of that. At least when x is non-negative. Is that okay? All right, cool. And now we look at E10 and go like, well, we are adjusting it by division by 2, so maybe we should not touch the exponent of 10, but we should do something about the E2. So what should we do about E2 now? The coefficient is halved, which means there's a division by 2. So what should we do to E2 to maintain V, which is the value that it is representing?
Decrease it by 1?
Increase it by 1. Because if you do a division, then you have to bump up the exponent
To make it equivalent.
to make it equivalent. Right. So we have to bump it up by 1, like so. And now we want to check these two. One is to see if we have preserved the value, and the other one to ask, do we have room for another multiplication by 10? Okay, it's all good. And then we're going to do it again, right? So we'll do it one more time and go like, we're still good. So at this point, we have divided the coefficient by 4, which is division by 2 twice. And this is the third time, and this is the fourth time. And this is going to be the fifth time. Oh, wait. I was just being stupid here. Because this condition should not be room for another multiplication by 10, because we are trying to see if um, room for multiplication by 10. Um, okay, give me a second here. I can actually hear my own brain fart. All right, so this is the last value, because if we bump it up one more time, then it cannot do. Oh, I remember I forgot one thing. That's why E10 is still 70. Nope, nope, that wasn't it. We want to, let me just count the zeros. 1, 2, 3, 1, 2, 3. This is the value that I'm supposed to use. I take it back. I am so sorry that I made a mistake. This is the value that I'm supposed to use. Okay, let me explain that. Okay, when we had this value, the answer is still true, which means I can multiply the value on row 8 by 10, and it will still fit in a 32-bit unsigned integer, right? So that means I can do it one more time. This is the last value. If I multiply the number on row 9 by 10, then it won't fit in a 32-bit unsigned integer anymore. Is that okay? And that is why we should have started with the number on row 9 and not the number on row 8. All right, so now it makes a lot more sense, because at this point, I have no room for another multiplication by 10. Divide it, divide it, divide it, and finally, now we do have room for another multiplication by 10. And that is the value that we need to use to multiply by 10 again. Is that making any sense to you?
Why isn't 71 the exponent of 10? Why is it 72?
because I never did any thing in base 10. Because every row is only a division by 10, a division by 2, sorry.
Mhm.
So when I'm only dividing it by 2, I should only adjust the exponent of 2. I should not touch the exponent of 10 at all.
I think he's saying it's like 71 is the exponent of 10
Yeah.
for that new number that we just brought up, and then the G column should be changed to 71. I think.
Yeah.
Because we just changed them.
Yeah, as far as 71, the other call on the other side.
Right, okay, I see what you mean. So this should be B9. There we go. Yep, you're correct. Thank you. Because otherwise, this number doesn't would not be preserved. I mean, if I did when I did it before, before I made a mistake of B8 here, you can see how this number is not exactly the number that I started off with. Good job. Thank you. Thank you for noticing that.
So,
Mm-hmm.
I don't mean to derail the whole like class, but on the last one we were doing with the opposite,
Uh-huh.
we used the value that was true before, like you just did before, but
Mm-hmm.
on your spreadsheet, we didn't use the first value that was false. Is it still true or should it have been changed?
Well, that's because of the condition that I'm using to check when I need to get out of the loop. So this time I'm checking to see if I have another room for another multiplication by 10. So that's why, as long as I still have room for another multiplication by 10, I should not exit the loop.
Okay.
And then over here, it's still asking the same thing. Do I have room for another multiplication by 10? I do not. So we need to have the coefficient and ask again, do we have room for another multiplication by 10? Nope. Let's do it one more time. Do we have room for another multiplication by 10? And the answer is still no. Now we do. Is that okay?
Yeah, I was asking more specifically for the negative one, the one we did
Yeah.
last one. But maybe I'll just ask after the lecture.
Okay, sure. That works too. All right, so we know this is the value for the next column. So now we put that column over here. But this time I'm going to build in an adjustment when I copy the value over. So the new coefficient is not exactly just this thing. It's going to be this thing times 10. So we're going to have the coefficient being what we had here, but multiply it by 10. So now the E10 is going to be whatever we had here minus 1, and then E2 would still be preserved as the other one. So it's going to be 3, and then V and room for X10 is just copied from there. Okay, so are we understanding what this part is about? The cell, let me see, the cell F5, okay, let me click that first. So the cell F5 is giving us a coefficient where we just barely have room for another multiplication by 10, which is what we want. Because every time we multiply the coefficient by 10, we can decrement the power of 10 by 1. That is what we want. Is that making any sense? So that's why when I copy this value from F5 to K2, I'm building in a multiplication by 10 because that's what I'm intending to do. But at the same time, we also have to say, okay, but the exponent of 10 is also going to be 70 instead of 71 because the multiplication by 10 to the coefficient means we can decrement E10 by 1, or we should decrement E10 by 1. And you can see how the math is working out because V is preserved this time, and we do not have room for another multiplication by 10, which is not surprising. Is that okay? So now what we do is we keep division by 2 again. Okay, let me highlight all of these. And now we basically apply the division by 2. So the division by 2 cells are from here to here. So I can just copy and paste it at this point. So this is division by 2, not quite enough. Okay, in other words, if I multiply this number by 10, it is still exceeding what we can represent using a 32-bit unsigned integer. So that means what? What should we do next? Divide it again. Yep, divided by 2 again, and we look at this and go like, we still don't have enough room. What should we do again? Divide it again. Divide it again, and not quite. What should we do this time? Again, exactly. Now, this is important because last time we only have to divide it 3 times so that we end up with enough room. But this time we have to divide it 4 times to get enough room. So that means you cannot just count the number of times you divide it by 2. You really have to check whether there's room for another multiplication by 10. Why is that the case? Why is it sometimes 3 times and sometimes it's 4 times? It has to do with the values 8, 16, and 10. Two to the power 3 is 8. 2 to the power 4 is 16. Where's 10? Between them. So that is why most of the time you can just divide it 3 times and then you end up with enough room. But occasionally you have to divide the coefficient by 2 4 times to make enough room for another multiplication by 10. Is that okay? So do not just rely on the counter. This time you really have to do the comparison to find out. So I'll do this one more time just so that we get into the regular cycle. So we look at this number and say, if I multiply this number by 10, it will still be containable inside an unsigned 32-bit integer. So that's what we're going to do. So now with this cell, it is going to be this cell here times 10. And then the next one is going to be whatever this cell has minus 1, because this is giving me the space to subtract 1 from E10. So let me put the header first. So this way you guys can see what each column is representing. E2 is a straight copy because we are doing something in base 10 but not in base 2. So the 7 is just going to be preserved. And then we have the V and the room for x10 or times 10, and they're just going to be copied like that. So we can also double check to make sure that we are still preserving the same value. And now we're just going to do the division by 2 again. So division by 2 is done by these cells. So now we say, nope, not enough room. This time it should only take 3 times. Yep, there you go. But can you see how we are using this approach to bump the exponent of 10 down by 1 every time we advance to the next 5 columns? We good so far? Okay, so now we can go back to the example on Monday, the negative exponent example, because we had a question about that.
Yeah.
So let's check that. I'm gonna go by last modification time, so this way so that would be this one. All right. So this is the spreadsheet that we looked at on Monday, and the question is.
So if you scroll down,
Okay.
and you take a look at the coefficient, and the last value that's false there, it doesn't match up to the F column. Scroll up to the scroll.
Oh, okay, I see what you mean. Okay, that is because by this time, the value of the coefficient has already exceeded.
Just
So-
like it did in the new example, right? So that way we use the first one that was false.
Well,
try to break it down.
Okay, but you have to look at the condition because you have to look at what the condition is testing. So in this case, the condition is testing, not asking what if I multiply the coefficient by 2 again, whether that will fit in the 32-bit unsigned integer. This is asking whether the coefficient itself would fit in a 32-bit unsigned integer or not.
By itself.
So it's not the same kind of condition. So if you want to make this code more equivalent to the code that we looked at today, then you have to change the condition here to ask not whether the current coefficient is going to fit within a 32-bit unsigned integer. You have to ask, what if I multiply by 2?
Oh, okay.
So that's the only difference.
Okay.
So if I did that, then you will see the false is going to move up by one row, which resembles what we did today.
Oh, okay, gotcha.
Yeah.
All right, thank you.
So it really has to it boils down to what we are testing. Are we testing whether the coefficient itself is less than the largest number, or are we testing twice of that is less than the largest number?
Okay, cool, thank you.
I have a question.
Yeah, go ahead.
So how come in the other example, we didn't have a few rows that were false before we got to true, whereas in this one we do? Like here, we right away, the first thing is true. It's like we're ready to go. And then in one today, we had a couple of rows, 3 or 4 rows.
Because I'm testing the reverse of what I need. So this, okay, if you look at these conditions, I can I can make these consistent. So we are testing whether we have room for another multiplication by 2, right? So this is the last value, because if I multiply this by 2 again, it's going to exceed what a 30-degree integer can represent. And that's forced me to have to say, okay, we cannot double it anymore. So now we have to do something about the base 10 thing, which is, in this case, is division by base 10, by 10, right? So what we did today, which is the other spreadsheet, okay, ready? This is the other one. So this one is asking, do we have room for another multiplication by 10? That's why you'll be, all right, so the key has to do with this part here, because this is basically this value here. Okay, let me use the correct one. Okay, this one here is 10 times, let me see. Okay, this one is the same as this value here. And what we are trying to do is, how do we make the coefficient? How do we change the coefficient so we have room for another multiplication by 10? So we have to keep doing this loop here, keep dividing it by 2, basically, until we have room for another multiplication by 2. Now, in the other program, the question that we were asking is exactly the opposite. Because in this case, we are asking, can we double it again?
You're trying to divide and you're trying to
Right,
multiply.
exactly. You can see how the coefficient in this case is doubling every single time. And then in the other one, oops, not the other tab, but the other actual spreadsheet. With the other one, we are halving the values for each row. So that's why the one is looking for a true and the other one is looking for false.
In the beginning, you're increasing them.
That is correct, because in the beginning, I'm just being lazy. Because in the beginning, I could have done it this way and just go like, oh, we can, but then it would spread out to a lot more columns. Okay, because, okay, do you want me to show how that would look like if I were to use the same logic, but use the column expansion instead of row expansion to do the same thing?
Yeah, if it.
Okay, yeah, I can duplicate. This is the nice thing of using a spreadsheet instead of doing everything on the whiteboard, is I can just do this. So now I have room to play. Okay, so if I were to use the same approach, because the way we transition from the first 5 row to the second 5 row, oops, the first 5 row is from here to just, okay, it won't let me deselect it. This is the first 5 row. So the transition to the second 5 row has to do with the fact that, yep, we can multiply by 10 now, right? So if I were to use that approach, but do it in a different way, then I would, okay, let me, I'm just trying to figure out, how to best represent this. Okay, I think I can do it this way. So I'm just going to get rid of all of this stuff here. And it doesn't like it because the references are all wrong. But basically, at this time, I have room for another multiplication by 10, right? So what I'll do here is I'm going to say this thing here is going to be this one times 10. And then the new E10 is going to be what it used to be. Oops, I have to type equal what it used to be minus 1. And then E2 has to be preserved. So it's going to be the same as this. And it is true. It is still true that we have another room. So that means there's no need to divide it by 2. Does that make sense? So in sheet 1, in the original sheet 1, I'm simply trying to save a bunch of columns because otherwise this is going to take up 5 columns. Oops, not that. Okay, maybe this is going to take up 5 columns. This is going to take up another 5 columns. This is going to take up another 5 columns. But with those particular columns, there are no division by 2 because even after I multiply the coefficient by 10, there's still plenty of room for another multiplication by 10. So if I want the logic of the program to be consistent with the geometry of the spreadsheet, this would be the way that I need to do it. But it's going to take up a lot more columns than the other way. Is that okay? Yep. All right. That's a very good question. But basically, if I did it this way, using a lot of columns, the geometry of the spreadsheet would be more consistent with the actual control structure of the program. The reason why that is the case is because when we transition from the first 5 columns to the second 5 column, that is one iteration of the outer loop. Within each outer loop, if I have to do something like this, that is the inner loop. So this has to be done using a double loop structure where one loop is nested within the other loop. When we transition from the 5 columns to the next 5 columns, that is representing one iteration of the outer loop. But when we do things within the 5 columns, but only do the row changes, it is representing the work of an inner loop. That is also true for the other spreadsheet. So if you go back to the spreadsheet that is actually relevant to what you need to do right now, this is also reflecting the same thing. In other words, A, B, C, D, E, the columns A, B, C, D, E, that's representing one iteration of the outer loop. The columns F, G, H, I, J is representing another iteration of the outer loop. But when you look at the rows of the 5 columns, each row is representing one iteration of the inner loop. So that basically kind of spells out how you need to structure the loop. You know you have a double loop. You know what the outer loop needs to do per iteration. You know what the inner loop needs to do per iteration. So this is kind of a graphical way of looking at a double loop structure, except it shows you, what happens after each iteration. So are we okay so far? Are we clear enough with the spreadsheet that we talked about on Monday to get your project started for today? It's good. All right. Okay. My recommendation is not to rush into the project. Instead, pick some other value. Okay. Pick something that I can even give you a recommendation. Pick something like 1.2345 times 10 to the power of negative 40, okay? Just so that you have a different starting point, okay? Try this one. You try to use the spreadsheet approach just so that you know how to approach it. Doesn't have to be spreadsheet, okay? You can just do it on a piece of paper. You can do it on your iPad, but just to make sure that you know manually what to do with this. Because as you do it manually, you notice, oh, okay, I need to do this again. Every time you think, oh, I need to do this again, that's a loop. Every time you say, I don't think we should do another iteration, I cannot do this one more time, so think about why that is the case, because that why is the condition of the loop. We doing okay so far? All right. So you got 1 week to work on this, which means next Monday is a lecture where you can bring back your questions, especially during the lab time. So let's just say that you spent a lot of time, from today over the weekend to work on this, and you got stuck somewhere. Okay. Next Monday during the lab time would be the perfect time to bring your program to class, and then you can then ask me, okay, I'm kind of stuck, my program seems to be not working, it seems to be stuck in an infinite loop, and then I will try to answer your question. Yep.
We can also reach out by email if we're like, we go home and have a question or something.
Yeah, you can.
Like,
Yep.
through like Thursday or something.
Yep. But I will be very mean the day before the due date.
Oh, no.
In other words, if I see like 20 email popping up at 10 p.m. the day before the homework is due, I'm just gonna go sleep. I'll just pretend, no, I did not see that. I'm gonna go sleep now. So you have been warned. Because I'm not gonna stay up.
2 days.
No. 2 days fine. 2 days before is fine. I just don't want to have to stay up until like 2 a.m. because some people decided, this will only take me like 6 hours to do it. All right. Any questions? So remember the spreadsheets. You can make a copy for yourself. So that way, you can annotate by inserting comments, which I think is a great way to kind of document the whole thing and integrate your thoughts and your understanding into the spreadsheet itself. We are good so far? Okay. All right. So with that said, the lecture is over. I'm done with the lecture. So we are transitioning into the lab time. Oh, before we go, let me ask you one more question. Do you find the lab unit of most CISP classes useful, or do you think, okay, we can probably live without that one unit of lab?
The lab is useful in all.
Useful?
In every
Okay.
class I took, the labs were very useful.
Okay, so let me ask you another question. What if the class is 100% online and it is asynchronous?
No more. No more.
In that case, what is the lab?
Right.
The lab makes no sense, right? There's no meaning to what they call a lab when the class is 100% online and it is asynchronous.
It costs more, so.
It costs more, exactly.
More money for
I
Yep.
remember.
Go ahead.
I was playing League of Legends in my online class lab, so it was very
Okay, wait, but are you playing just a bot game where you can go like, yeah,
No,
I
no.
can catch up later?
You can't just play one.
Because if you're good at it, you can do a 1v, just have the bot controlling the other
Oh.
allies,
Yeah.
and you can still make the big difference and win the whole game
Yeah.
if it's a bot game.
Yeah.
Yeah, but you weren't playing a
No,
bot game.
no bots. Rank queues.
So in addition to actually playing the game, you also have to handle all the salty players from your own team.
Everybody's salty in League. And literally everybody, including yourself.
They have to come with that, like all the food items, like how many percent of sodium, right?
Yeah. There's actually a league code problem about League Teemo attacks. It was a really interesting one. It's like a sliding door type problem.
I wonder who has the call sign of 100% sodium.
Oh.
How salty are you? I'm
I'm
100%.
100% solution.
Yep, I'm so saturated.
No water.
That would be funny. All right, well, the lecture is done. I mean, if you guys want to, continue and just make sure that you can get started with the project, that's fine. If you want to go like, oh, I can work on this on my own, that's fine too. Let me stop the recorder first, and then I'll start to answer questions. Give me a second to stop the recorder.